My name is Dirk Jung. I'm a senior sales engineer at Snowflake. So senior solution engineer is a new name. I forget it sometimes, but it's the same. Yes, today I will show you how you can create in Snowflake with Python your own pipeline with a scalable with regards in compute power what you are needing. And for me, I'm very happy to be here on the stage. I'm an old guy. A couple of years ago, so in the 90s, I studied computer science here in Darmstadt. And as I studied here computer science, it was not a place for the dumb stadium where the conference is today. It was a parking place for the students. So unfortunately, I have no less parking place, but we have this nice building here to present many concerts or congresses as well. Yes, not sure if everyone knows what is Snowflake. Snowflake is a company who has there's a cloud data platform. It's built for the cloud, and we have two founders. It was founded 2012 by two French guys, Terry and Benoit. Both are passionate winter sporting people. They like it to snowing and all these things, and this is the reason why they give the company the name Snowflake. It's one of the funny things, and the second is it's where the snow comes down from the cloud, so it's algorithms to see it comes from the cloud. And I started 2020 at Snowflake during the corona pandemic, and as I started, I was employee number 2,000, 2,500, not sure. And our first revenue was we going public in September 2020, and our first revenue for the first year was 500 million in 21. And the last financial year was 25. We have a revenue of 3.5 billion. That's amazing, but what's more amazing is for me, we have now 8,000 people who are working for Snowflake, and from 8,000 people, 2,000 or 2,200 working in the sales, the research and development department. I work in the sales department. So we have a really powerful workforce in Snowflake to create new features, to launch new features, and develop many more stuff to make our platform more stable and bring new function what we see in the market requested by our customer. Yes. So as Snowflake was founded, we starting with a pure approach to say Snowflake is a cloud native data platform, and what we see in the past, you see it here on the timeline, as companies starting to collect data and store data in different silos, and they call it AIS. It was the Enterprise Information System. Then they store the data in the cloud, and again, more data come in, and they have more silos created, and Snowflake is a one data platform when you can store all of your data, semi-structured data, structured data, and of course, also unstructured data. And then you have your single source of truth. We see it, we're running now in the multi-cloud space. We have a lot of AI topics. So when you take a look in your daily business, maybe you use already ChatGPT or other Gen AI, things like Mistral or Claude. And we have also this new Gen AI features included in Snowflake. But what is Snowflake? So we talk about in Snowflake, we are a data and AI platform or data and AI platform cloud. What we think about with the cloud is we can connect to every Snowflake account. You have not to move the data, so you can connect between different accounts, and then you can get access to this data when it is allowed. And we have 4 of the typical workloads which we covered. The first one is, of course, analytical pace. The next one is AI. Then we have also the data engineering path. And it's also possible in Snowflake to create your own application and share this application so that you can also share data. What is the benefit of some of the USPs of Snowflake? We are very easy. So we have a Snowsite UI. We take a look afterwards. So I will also show it how it works in Snowflake. And we are scalable. So it doesn't matter if you have 10 terabytes in Snowflake or 100 petabytes. If you need 1 compute resource or 500 compute resource, the cloud make it possible. So we take this resource as the customer need it, and you pay only for the time where you use the resources. We call these compute resources, by the way, virtual warehouses. Today we will take a look how we bring the data into Snowflake. So we have pipelines, how we can load the data into Snowflake when you store the data on a specific place, maybe on a S3 bucket or in Azure blob storage. Google storage is the same one. And then you have to transform the data in the right shapeness that you in the end have a table or a view where you can say, okay, this I will use to report this data or create my own models to make forecasts, anomaly detection, and so forth. But before you can do this, you have to load the data in the Snowflake. And as I started in Snowflake, we do this with SQL. SQL is an old language. I learned it years before. Then I saw that this Python is much more easier. But with Python, you have to create your data frames. So a mix of both language is a good choice from my point of view. And how we do this to create this pipelines, it's quite easy. So we have a base table where we load the data into it. Then we create with our task a new table and load the data in it. And then in the end, we have a stable pipeline where new data are loaded into the stage, for example. Then we have maybe a notification. This notification triggers the task. The task said, okay, I load the delta into Snowflake. And then I will start a transformation job till the end. And in the representative finalized layer, I can use the data for my workloads, like to build a model or run a model on it, or to report the data or make deeper analytical workloads. Yes, and as I mentioned, we have a strong workforce in research and development. So in the past, it was possible to connect you with different tools. So Snowflake Jupyter Notebook is a very popular one. So we introduced our own notebook. The benefit is you have not to think about it, how I can connect to Snowflake, what I have to thinking about the data governance and so far and so forth. It's all included in our notebooks, and you can use notebooks to write Python code and also, of course, SQL code. And it's based on our Snowpark feature. Snowpark also allows you to code in Java and then scale it directly into Snowflake. And to see how it works, I use this picture. This is a quick start. In Snowflake, we have many quick start. When you go to your browser and search for Snowflake and quick start, you will find maybe 50, 60 of these quick starts to different topics. Could be how I load data into Snowflake, how I use an OpenAI model, how I use it maybe create with Snowflake AI my own forecast pipeline, and so far. And every of these quick starts have a guideline, and it walks you through step by step how you can use it. You see the link here. This is for this specific quick start. You can, if you want, try it by yourself to check how it works. What we will do, we see it here. We're starting here with the storage. The data are stored in the S3 layer. This is typical layer where we get the data. For us, we create a stage on top on this layer. And the idea is we have here a franchise company. This franchise company has food trucks all over the globe, so in many countries, many cities. And we see some positioning information like the countries, franchise, location, and menu. We will load all this information into one layer. This is our raw layer where we load the raw data into it. But we will also know what has happened when the weather condition will change, or will analyze it in the first step. So we have to connect weather data with this. And we have not to load this into Snowflake. We can connect directly with Snowflake the weather data. So if they refresh the weather data, you see it immediately. You have not to run again an import job to see what weather data we have tomorrow or in the next couple of hours. And a typical way when you take a look on a warehouse, then you will, of course, harmonize the data, calculate some things. So the raw data which we receive here have some small pitfalls. The decreases in Fahrenheit. When I see 65 Fahrenheit, I think it's very warm, but it's cold. It's okay to know it's 20 degrees or 15 degrees. And the second thing is, of course, inches is not so in my mind as millimeter. When we see how many rains comes down, is it 2 millimeters or 0.3 inches? It's for me different to understand it in my mind and calculate it in the right size. I'm a metric man. And of course, it makes sense to have objects in Snowflake which make this task. So they will automatically, when you load data into Snowflake, we call it UDF. We will also walk through to it to calculate my weather from Fahrenheit into degrees Celsius, the same one from inches into millimeter. And in the end, you see it here on the point 7, we will have one table where we see the daily orders per city and per country to make better analytics and understand where's the best places. Maybe we can also arrange go a bit deeper when we have more places, which places are work better in different work days. So this is the idea behind this example. So to see how it works, I prepare a demo, so I feel it be almost better when it have some slides, but I can also see how the software is working. Yeah? So let me step here out, and let me step in here into, this is Snowflake Snowside. This is our UI, which you can use in Snowflake. It's quite easy. You have some areas here for different projects, and as mentioned, and we want through this notebook. So I start this notebook and take a couple of seconds. So we see it. This is the original notebook, but you also can use in this quick start what I mentioned. And I get some explanation here about it. You see here which kind of task we will doing. This was the picture again, what I showed beforehand. You get here some information what is in it. So we have the markdown cells here. We have also SQL cells, or we can work on it. And the first thing what we have to do is we have to prepare the scene to say, okay, which role I will use. Snowflake had an integrated role-based access model, so we will create a new role, and this role should have all access for the specific task. Not to say, okay, maybe I have also in Snowflake included credit card information. This is not a data that we should see every member or every employees of my company. The same as with social security number. These are sensitive data, and this data have to be carefully and secure. Only people who's allowed to see this data should see this data. This is the reason for our role-based access model, which is based on objects and only with roles. Nobody, no user can have rights on any of the objects in Snowflake. It's only the roles. So I hope the internet is fast enough. It looks like so here that we can walk through on it. The next thing is what we now do. We create a database. We create a dedicated compute. We call it, as I mentioned, virtual warehouse. So this is isolated only for this workflow. I'll use one compute, and when our compute's running in trouble, maybe queuing or so, it has no impact on my workflow here. So this workflow runs dedicated with an isolated compute in this case. So let me do this. So this is quite easy. So we create a database with different schemas. You see it here. We have an external schema. This is the connection to my data, where the data are stored. So we create, in this case, a stage. Then we will load this data into my raw position here, whereas I have the base tables with the countries, with the orders, and so far and so forth. And then we harmonize this data. And in the end, we will create this analytical table where we can make our own analysis with our visualization tools. Yes, and let me step here. So this is the first step. So we will prepare in this session how we can load the data with Python. So I write here some code with data frames. I'm not the Python expert, but it works. I do it many times. And we will now import some information here for Snowflake utility functions. And in the next one, we will also the active session get, so that we have the right positioning for the data which we will load into Snowflake. And now we're starting loading the data for every table into Snowflake. This takes roughly 2.5 minutes, but it's okay. So I can explain what's behind Snowflake, what makes Snowflake so unique. So as I mentioned, when you have 10 terabytes, you can working with 10 terabytes, and you can working with 20 terabytes or 100 terabytes. In Snowflake, compute and storage is separated. So if you need more space, you get a space. You have not to say, okay, I need more space, I need a new hard disk. So in the cloud, you load once a day 10 terabytes, the next day you can load 15 terabytes. It's not a problem for Snowflake. The second thing is, the compute is separate from the storage, and the compute is separate from the compute. So when you create a new virtual warehouse, you assign this warehouse to a workload. In my case, I assigned this warehouse for my data loading workload with my pipeline. So this next one will be maybe a warehouse for data science purposes, and the other one will be for reporting purposes when I have a tool like Power BI or other tool visualize this data. The good thing is, so when I see I have a problem, maybe I have a huge workload and it takes too many time, I can stop this task and increase my compute in less than 1 second. What will this mean? In Snowflake, we have different types of warehouse sizes. We're starting in t-shirt size with XS, this is one server, till 6x large with 512 servers. It's much more faster as one server, of course. And it takes me 1 second to scale out from XS to, for example, 4XL. And it takes me 1 second to decrease it from 4XL to S. That makes Snowflake so unique that when you need more performance, you get the performance. You click on it, you can work on it. And you can do it also here in a Python script that you say, okay, I know in the next step, maybe this one, I have not changed the warehouse. This is the reason why we need roughly 2.5 minutes. I need a bigger one. I run at the moment, so I guess with a warehouse size S, but it makes more sense for this load to use maybe a large warehouse, and then I'm much more faster than 2 minutes. So this is easy to use in Snowflake. You only have to do it with one click and say, okay, give me a bigger warehouse, and then you can use it. So now we have loaded the data. It was faster than last time. We need only 2 minutes. And when you take a look on the data, we will look, is this the right one? And the next thing what we will do is we see here we have a schema detection. We load Parquet files into Snowflake so we can automatically transform this data into a schema, so to load it in a standard table in Snowflake without any other workloads or doing, by the way, that you said, okay, I have to do it outside of Snowflake. No, Snowflake had integrated this schema inference, so we detect the schema and can load it directly in the table and copy it in Snowflake. So now we have the base table stored in Snowflake, but I need also the weather table, or the weather data. So to combine it together in the end in my final table. So for this reason, I have to load weather data, or link, not to load, link weather data to my data here. And I can see it also here in the database. We have already created, even during my speak, this new database. This is the hands-on lab with the schemas, with analytics, external, harmonize, and so far. But I don't see here on frostbite weather. So you see here what frostbite weather source, and we'll do this now in less than, I guess so, a minute. We go to data products. This is our marketplace, and search for it, or it's highlighted. I often use it. That's the reason. So you see here, some of them are free. Some of them you have to pay for it. So it's by request. So you can monetize your data. So you see we have so many data products for different, business. This could be, I'm waiting for this one. It's not so fast as a deck. So geospatial, financial information, or e-commerce. But for example today, we will only load the weather data or assign the weather data to my account. The only thing I have to do is I will get the data. Then I need a name which I will use for the database. In this case, I have to use this name, otherwise my script will crash. And I have to assign a role to this database who get access. That's it. So it takes 20 seconds, I'm finished. So if now the provider of the data will update his data, I see it immediately. So I see when he updated his data, the update also in my account in Snowflake. So when we go back, and we might have a refresh here, so we see here the frostbite weather source data. So it was only a click, and we see here the data is different with the views. We have forecast for days, for hours, and so far. And postal code, of course, we have to assign it to the right postal code. That's it. I bring data from outside into Snowflake without loading this data. Only link this data into Snowflake. That's perfect. So, and then, of course, I make some privileges setting here to see if it works. If I have the right one, it's only a check here. Yes, we see we have here the postal code for England. This is my first check. And in the next one, we can create with a Python statement a view. Maybe you can do this again. Take a look on the watch that we're in the time. So you see, this is when you write this in SQL, it costs you more time. You have to write maybe much more line of code. In Python, when you use Python libraries, Python function, it make it faster for you. Especially when you will calculate, for example, KPIs. Yeah, for KPIs in SQL to calculate it's harder than when you have a library in Python, or for other scientists to use these libraries. It's much more faster and comfortable to use this here in my notebook. And in the end, we will then set a session to this, create this one, and then it's finished. So we have our view, the view we can work on it, and the next idea is how I can load the data continuously into my database. So I've loaded once a time the data in Snowflake. The next thing is to load it continuously. I will have a pipeline, and for this pipeline I need CDC, so I will avoid that I have duplication the data from the base table. And for this one, we have streams in Snowflake. Streams is an object directly on the table. And when you load on the first time the data into a table, maybe you have 20,000 records in the table, then it is finished. And then you set up on this table a stream, and you load 5,000 records. These 5,000 records will be in summary 25,000 records in the table, but in the stream I see the 5,000 new tables, 5,000 new records, and I can see is it an insert, is it an update or a delete, and then I know how I have to handle with this data, and it takes true that I can in the end only data which are need load into Snowflake, no duplication. Okay, so the next one, what we're doing here, is we will also create a user-defined function. What is a user-defined function? This is an object in Snowflake where you can use from different pointers. You can also create this function and invoke it from SQL, also in Python. And with this user-defined function, I will calculate Fahrenheit into degrees Celsius. The reason is people from Europe, again, cannot understand so good what is 65 degrees Fahrenheit to understand this is hot or warm. And this will be also add to my pipeline. So every time when I load new data, the transformation steps, my pipeline generate also a new column, or the column already exists. Then it's calculate the values and said, okay, 65 or 63 Fahrenheit is this in degree Celsius. Okay, so we saw it's a lot of things how we can load data into Snowflake. So we create our own database only with Python code. And let me jump in one of my other accounts. This is the same what we did, but to take a look on the data. So here in this account already I have run all the scripts from the notebook. And we take a look here also to the database, and we see it here again. This is my database, and we see here where the external data comes from. So it's from a stage. I give the stage the name Frostbite raw stage. It's okay. I will enable the table directory. The reason is I will see which data are included here on my stage. So it's the direct access to the S3 bucket with the data governance of Snowflake. So if I have not the right to see the stage, I cannot see what is in the S3 bucket. Only when I have the right to see, take a look on the stage, then I can see which data are stored in this S3 bucket. Not sure which was the most funny one, so I guess this one. So we can take a look in the years, and we see there's a lot of data which we loaded in the step before. When we go back to the order details, we see this is 4 gigabytes, 2 gigabytes. There's a lot of data in the end, I guess. So we loaded during the loading job in the notebook roughly 20 gigabyte into Snowflake. The next thing is I have here my, not this one, raw position tables based from my S3 bucket. I loaded this data into my country, into my menu table. I can also say, okay, show me where comes the data from. I see it comes from this stage. So in this example, it's easy to say it, but when you have a bigger warehouse, a large warehouse with many pipelines, you will see what's the source of my data. In this case, the source of the data is the stage. Sometimes maybe comes directly from an ETL tool, or you can also stream the data into Snowflake. That's also possible. So it doesn't matter. So in the end, yeah. So, and we also create here, let me go to my harmonized schema tasks. So when I click on this task, there's only 2 tasks. When we run this on a real production environment by customer, when we see this, there's more than 2 tasks here. This task will detect if new data will be stored, also files will be stored on my S3 bucket, and get a notification, and they start the pipeline job to load this data first in the raw data, then into the view, and then harmonize it, and in the end, it's create this analytical table. So this one, this is the product what we want to see in the end. So we can also do here lineage, but it depends on the orders, makes sense. We cannot see the impact from the beginning of the source, but we will also add more features here on our lineage. And I can take a look in the preview to see what data are in it. So I see here the different names of the cities. I see the country. I see the number of sales for our daily have. So 79,000 food pieces. That's a lot. You see here the temperature in Fahrenheit. We see it what it is in degrees Celsius. And the same we see it also with inches and millimeters about the rain what comes down. Okay, take the time. So I saw how I can load all the data into Snowflake, and now I will analyze the data. So with Snowflake, so it's seamless. So all things what they're doing now is it's based on the platform. I have not to load data from everywhere, different areas into Snowflake, and say, okay, I need some more information, and comes from another system. So we can all do this in Snowflake, and I will analyze this data. And for this one, we have Streamlit in Snowflake. So I'm not a good designer, but I create a small analyze part here to see which food I have sold in different cities. I have to wait a couple of seconds till it's finished. So now it's finished. Give me a second. I think it looks like nice here when I have the dark mode. Yes, better one. So now I can. So this was not. It was too fast. Step back to my Streamlit. Take a couple of seconds again. Sorry for that. Was a mistake from my side. So I will select the date. For example, here from the 1st of January 2019, so we have only data till 2019 here. Okay, that's it. And do this maybe for the first quarter. So the first quarter will be in March, ending on the 31st. And
sorry, we're a little bit behind schedule already.
Yes.
And we have a lot of questions in the Slido.
That's it. So only one thing you see, it works. So I have here the data in Canadian from Montreal, or I can switch over to Toronto in seconds, and only to show it to you, this is the code. It ends here with line 36. I need only 25 roughly lines to create this small analytical part. Thank you very much.
Thank you. So we have a lot of questions. I will just try to take some few. Say, does Snowflake keep partial result of computations when changing scaling configuration for an interrupted task?
So
do you want me to take it again? Does Snowflake keep partial result of computation when changing scaling configuration for an interrupted task?
Sorry, I haven't understand it.
I think it's talking about.
Can I read it?
Okay, yeah.
Which one is?
The first one. I think it's talking about scaling and during scaling.
When you interrupt a job was running, then you lose it, of course. You will scale up, you can run it again, but you cannot, through the process, when you run a query, change the size of the warehouse. This is not possible. Okay. But if you run maybe since 10 minutes with that is too long, then you stop it, create increase the size to bigger warehouse, and you can run it again to see if it runs then true in 2 or 5 minutes with the result.
All right, thank you. There's a lot of question about scaling. He said, is there an auto-scaling function to scale up and down the warehouse?
No, there's no auto-scaling. You can do it by program, of course. First thing, so it makes no sense. So otherwise, you're running out of costs. If you said, okay, I'm the owner of this platform, and I'm responsible for the cost of the platform, I will not allow that anybody said, okay, I will scale up a warehouse from XS to 6x large. The cost is much more higher, 500 times, and run only a simple select statement. That makes no sense. So you can only do it if you have the ability, so to have the rights to scale a warehouse, and automatically it's not possible, but we have multi-cluster warehouse. If you have a lot of queries doing maybe in the morning when many people run their reports, we can spin up a second, a third, a fourth, up to 10 of these warehouses, so that the load balance is the same one. You expect to see the result in 10 seconds and not in 2 minutes when queuing these warehouses. This is working.
Yeah, thank you. I will just take this last one. Maybe I will send the rest to you on Discord. How does version control work within Snowflake?
Sorry.
How does version control work within Snowflake?
Warehouse control?
Version control.
Version control.
Yes.
Sorry, version control. This was my. You can use GitHub. You saw it. Yeah, you can connect to GitHub for your version controlling. In Snowflake, you can also. We have a smaller controlling on the side where we have our worksheets. You see the different versions, but for the version control, use GitHub. It's the easiest way. We have a connector to GitHub.
All right. I think you will take the rest of the question on Discord. Thank you very much for listening.
Thank you very much.